All right, so we are doing 5.1 and 5.2. If you have a textbook, which you probably don't, we never checked any out, this is what this would correspond to in the textbook. Just to let you know about what's going on the next couple of weeks, we will have 4 learning days of new material, 5.1, 5.2, 5.3, 5.4, and then 5.5, 5.6. So 4 learning days. So that's this week and next week. And then the week after that will be study guide day and then test day. So your test will be February 10th. Today is January 25th. The February 10th will be your test. That's for A days. If you're watching this and you are in B day, yours will be the 11th. Okay? But we are talking about polynomial functions. We've done polynomial functions mostly this year. Our linear functions are polynomials, so our lines. Our quadratic functions are polynomial, but we also have powers that are higher than 2 that we're going to graph. Okay? So if someone asks you what's the degree of a polynomial, you're going to find the highest power, and that is the degree. So if I had something and the highest power was 3, my degree would be 3, and that would be called cubic if we look down here at our degree. Standard form of a polynomial is writing it from highest power to lowest power. So you start with your highest power term and you work your way down. That's like what we do in a quadratic, highest power all the way down to lowest power. And your leading coefficient is your coefficient in the highest power term. So if I were looking at this trinomial example here, my highest power is 2. The number that goes with that, the coefficient is 6. So leading coefficient, coefficients are the big numbers in the front of your term that has the highest power. Okay? All right. Every single polynomial can be classified by its degree and also by the number of terms. So by the highest power and how many terms there are. If their degree is 0, that's a constant. Your graph just goes straight across. It's like y equals a number. There's no variable at all. There's no x in the problem. It's just a number. That's called a constant. First power is linear, straight line, x to the first. Second power is quadratic. Looks like a parabola. This is where we get to our new ones. Cubic. Cubic graphs have 3 sections. You see how it goes up and then down and then back up? Third degree, 3 sections on the graph. That would be x to the third. Quartic graphs are 4th degree. They have 4 sections of the graph. Down, up, down, up. Down, up, down, up. We see those 4 sections. Sometimes they kind of cut one of them out, but the most they can have is 4. You might see a quartic that doesn't have quite as many, but that's the maximum number of sections of the graph it can have. A quintic can have 5 sections of the graph, up, down, up, down, up. Okay. Anything higher than that, if it's a 6th degree or 7th degree, we just spell out 6th degree or 7th degree. It doesn't have a fancy name. Right? So all the ones from 0 to 5 have a fancy name. Other than that, we just write out what degree it is. We also classify them based on their number of terms. A monomial has 1 term. This is 1 term. Binomial has 2 terms. 1, 2. Trinomial has 3 terms. 1, 2, 3. Okay. You always have to put them in standard form first, which means combining any like terms, before you determine what the degree is and the number of terms. So we're going to look at 2. We're going to name them by their degree and also by their number of terms. I'm going to add 1 to this. So on number 2, I'm going to put something at the end. I'll put +5. Okay. Just to make sure everybody's clear that they have to be in standard form first. So on our first problem, we have 6x squared plus 3x minus 4. What degree is this polynomial? What is the highest power that you see? Y'all can hold your fingers up. The highest power is 2, right? That's the highest degree. So it's a 2nd degree polynomial, so we know it's a quadratic. Are all of the like terms combined on this? Is it in standard form? All the like terms are combined? Yeah. So we know that there are 1, 2, 3 terms. So it's a quadratic what? Y'all can mouth it. Which type of omial is it? Trinomial, because there are 1, 2, 3 terms. So quadratic trinomial. Okay. Our second problem with the addition of that plus 5, is this in standard form? Is everything already all combined? No, we need to combine this negative 3 and 5. So it would be 7x plus 2. So first you do have to make sure that your like terms are combined. Otherwise, you'll have the wrong omeal. Omeal is not really a word. I just say that. What is our highest power that you see in 7x plus 2? 1, right? There's an understood 1 here. Our highest power is the first power. So first degree polynomials are called linear. You just go back to your chart. And there are 1, 2 terms. So it's a linear binomial. So first thing, check, make sure there's nothing you need to combine. Second thing, find the degree. Third, count the number of terms. Thumbs up if you're good separating the difference between a degree and a number of terms. Okay. All right, so that is the first part of this lesson. The second part is going to be the end behavior, and end behavior is how the arrows are going. So if you notice in these graphs that we drew, on our linear one, our first degree, the arrow starts down and ends up. So we call this down up. The quadratic is up up because both arrows are pointing up. The cubic is down up. The quartic is up up. The quintic is down up. And based on that pattern, what do you think a 6th degree polynomial would be? What do you think the arrows would be for a 6th degree polynomial? Y'all can do them with your hands. So we went down, up, down, up, down, up. So the next one would be, both of them would be going up, right? Because if you notice, 2 and 4, those were both up. 1, 3, and 5 are down and then up. Okay? So we can make a statement that odd degree polynomials, arrows go down, up, and even are both up, right? Based on that, you see how the odd ones have the arrows that are different, even ones have arrows that are the same? Nod your head yes, or do a thumbs up or something. Did you see that pattern that's being built? Okay, so we're going to fill out this chart here. Every graph that I drew in those pictures of those graphs have a positive leading coefficient. So we're going to do that first, and then we'll talk about what happens if we have a negative. Okay, so if we had even degree, and these the ones we just did were positive, both of our arrows are going up, right? An odd degree, the first arrow was down and the second arrow was up. We're going to write a statement for each of these arrows as well. Sometimes you see them just with arrows, sometimes it's with infinity signs, and sometimes it's a statement about rising and falling. Okay, so if something is going up, do you think that it is either that it's rising or if it's falling? Which one do you think it is, rising or falling? You can mouth it.
Rising.
It's going up. Rising is going up, falling is going down. Okay, so even degree polynomials, the ones we've talked about so far with the positive leading coefficient, both of our arrows are going up. So we write rise to the left. So the left arrow is rising. This is the left arrow. And we are also rising to the right. The right arrow is going up. The left arrow is going up. For odd, it's a little different. The first one's going down, so we use the word fall. So we say fall to the left. The second arrow is going up. So that would be rising to the right. The right arrow is rising, left arrow is falling. Does the vocabulary make sense there? Left, right is which arrow it is. Rise, fall is up and down. Okay. So that's if our leading coefficient was positive. That's the arrows that you'll use. That's how you'll know how to draw your graph, if it's up, if it's down, whatever. What happens if we put a negative in front of a function? What happens to the function? What does it do? It's going to flip upside down, right? So a quadratic normally goes both up unless it's negative, and they're both going to go down. So if we had a negative leading coefficient, we're not going to be up, up. We're going to be down, down. So a negative in the front tells us our graph is going to be upside down from our normal one. All the ones we've drawn so far are just normal positive graphs. So the statements that would correspond with this would be to fall to the left and fall to the right. Okay. An odd polynomial starts normally down and then goes up, but for this one we're going to swap. Okay. So we're going to swap. So instead of starting down and ending up, we're going to start up and finish down. You guys go ahead and write your statements here about falling and rising and left and right, and then we'll double check and make sure that you're good on those. This starts up, ends down. So tell me what the left arrow is doing and then what the right arrow is doing. All right, so let's check. This was going up on the left. So did you put rise on the left and down on the right? So falls on the right. Are we good with the verbiage? All right. So now we're going to put it into practice with given an actual equation. You're going to tell what is this graph going to look like? What are the arrows going to look like? Is it going to fall? Is it going to rise on the left and right, etc.? So when we're trying to figure this out, we want to know, is it a positive or negative graph, and is it an even or odd degree? Okay. So first off, is this graph a positive graph or a negative graph? Look at the very beginning. It is a negative, right, because of this. So that's a negative graph. What is the highest power that you see? 2. So our degree is 2. Is 2 even or odd? Even. So this is a negative even graph. So if someone asked you for the end behavior for a negative even graph, what would your arrows look like? How would they point? Can y'all show me how those arrows would point? A negative even, they're both going to be doing what? Going down, right? This is just like a negative quadratic. We've graphed lots of these. Remember, regular quadratics are a U and negative 1 is upside down, so both of our arrows are down. So negative even tells us down, down. Falls left and falls right. I'm going to abbreviate. That's an L and an R for left and right. So negative even, falls left and falls right. Both arrows are down. Sometimes it's helpful once you're doing that to kind of actually picture that this is a squared and it's upside down, so it's going to look like that. Our second example, is this a positive graph or a negative graph? Positive, right? It's a positive 7. If a positive graph, our degree is 3. Is 3 even or odd? Odd. So positive, odd. We can go odd, positive, go to our box. And we know that our arrows are down and up. And that's a falls left rise right. You can think about what a positive cubic looks like. It looks like this, down followed by up. There is a section of your homework where it gives you an equation like that and asks you to sketch a general shape. You're not actually sketching, you're just picking the right one. So for that, it might be something that's x to the 5th, and you want to find the one that's got 5 sections in it. Okay, it might give you x to the 4th, and you want to find the one that looks like the x to the 4th graph that we drew above. And you always want to check for positivity and for negativity for that. Okay. We've got a little bit left in our lesson. We're going to do the zeros in a minute. But first, I want to make sure that y'all are good on this. So I'm going to have you start your assignment right now. I'm just going to give you 10 minutes. I want you to see if you can get through the first 14 questions. You don't have to write anything down. It's just degree, leading coefficient, in behavior, and what the graph would look like from your pictures. Okay, so 10 minutes. So at 3:20, we'll come back and we'll finish the rest of it. Let's see if you can get the first 14 questions done in those 10 minutes. Pause the video.